So, hi class. Today we are going to study about adjacency list and adjacency list of a graph, as well as we will cover the recursive solution to the depth first search of the graph. So we will also cover the DFS traversal, as well as we will cover the adjacency list, and we will also cover like how you can implement a graph, how you can delete a vertex from a graph, how you can delete a node from a graph. So all these things we are going to cover in this video. So I hope you will enjoy it. So let's start it. So first of all, let us assume that we have this graph. So these are the nodes, and so let us say this is our graph. Okay, so let us assume that this is our graph. So let me connect these things. Okay, so let us say like this is connected to this node is connected to this, and similarly this node is connected to this one. Similarly, this node is connected to this one, and this node to this one, and this node is connected to this one. So now let us call like this is the node 1, this is the node 2, this is the node 3, this is the node 4, this is the node 5, and this one is the node 6. So we have all these 6 nodes. Okay, so now in order to make the adjacency list of this thing, and so I have already released a video for adjacency matrix. How do you draw the adjacency matrix for any graph? So now let us learn today how do you draw the adjacency list of this graph. So what we will be doing is the first thing we have to create for each and every node, we have to create a representation like this is there in the memory. So first we have to create in order to draw the adjacency list. So adjacency list for this graph. So we have to create like 1, 2, 3, 4, 5, 6. Okay. Now corresponding to each vertex, we have to define like this vertex is connected to with which nodes. Like 1 is connected with 2 and 3, right? Similarly, 2 is connected with the vertex 4 and 5 and 1, right? And 1. So you can see 2 is connected with 4, 2 is connected with 5, and 2 is connected with 1. Similarly, for this thing, you can say like your node 3 is connected with 1 and 6. Now node 4 is connected with 2, and node 5 is connected with 2, right? Similarly, we can say node 6 is connected to 3. So this is the adjacency list that we have at our hand. Okay, so this is the corresponding adjacency list for this graph. Okay, as well as so now we have to convert this thing into the logic. We have to convert the same thing into the logic. Okay, so this is the adjacency list. Now why we are going to do the adjacency list? Even we have the adjacency matrix also. So why do we need it? Okay, so why do we need it? Okay, why do we need adjacency? Okay, list. So basically what happens when we have the adjacency matrix, right? So let for these six nodes, if we are supposed to draw adjacency matrix, okay, so what we will be doing, we will be end up constructing a matrix of size 6 cross 6, at least 6 cross 6. Many people will say you to draw a 7 cross 7, but I am not among those. I will never suggest you to draw that thing, but you can see like 1, 2, 3, 4, 5, and there should be one more row. So you can see, right? And similarly, we should have the 6 cross 6. Okay. Okay. So now let us create. So now we have created 6 cross 6 matrix for this thing, and we will be defining like if there exists a node between 1 and 2. So we will go 1 and 2, we will make here 1. Similarly, we will go in 2, 1, we will make there 1. In the same manner, you can see, check my previous video to get an idea like how you construct the adjacency matrix. So why? So what happens here? Here if you check about for the space, so how many space it will consume? Let us say each integer or each true and false, okay, each boolean value, okay, take 1 bit. Each boolean takes one byte of space. Okay, so 1 bit of space, uh 1 bit of space. Let us say, just assume it is not the exact figure, just I am giving an example. So here, in case of this thing, so we have 6 cross 6, right? 6 cross 6. So we need 36 bits. 36 bits. Similarly, for an adjacency list, if we are going to do the same thing, we need, you can count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we need 16. So you can see considerably the amount has been decreased. Okay, but this will be much more visible to you when the length of this graph is bigger. Like in the Facebook, each and every user of the Facebook is declared by a node. Okay, at the backend, each and every user is considered as a node, and Facebook has millions of the user. So if we are going to draw a matrix of million cross million, million into million, so just you even can't assume like how much space it is going to take, right? So it will be very much costly. So in that situation, if you will draw the adjacency list, it will be much more helpful for you, because actually what happens here, this, when we draw an adjacency matrix, we consider that in the worst possible situation, it may happen that this node is connected to each and every node. So let me give you an example. Like here you can say, let this is a graph, and let this is this thing, and this is also, so this is also a graph, this is also a valid graph, right? And this is connected to this thing, this is also connected to this node is also connected to this node is also connected to this node, right? Similarly, this node, let us say, connected to this node is connected this, and similarly this node is connected to this node. Okay, and similarly let us consider like this node is connected to this node also, as well as yeah. So now you can see, and similarly we can connect all of these, right? So when you will go to draw an adjacency matrix, so you need the size of matrix. Actually, if there are 5 nodes, then we need at least 5 cross 5. We need at least and at most 5 cross 5 matrix to represent like which node is connected to which node. Okay, so that's why we need this thing. But this is the worst possible situation. But in our real life, it may never happen. It may never happen like every node is connected to every other node. So that's why in many of the situations, we might have to do something else. Okay, we might have to do something else. So what are the different things that we have to do in other situations? So now let us go some other. So now let me give you some example for the Facebook. So let us go to another page. Okay, so for the Facebook, let us see. So let us say Facebook has, just for the sake of convenience, let us say like Facebook has, I don't know what the exact data says, just let us say Facebook has, okay, let us say Facebook has 10 million users. I know there are actually billions people who are using the Facebook, I don't know, but let us consider only 10 million people. So is it ever possible that each and every person is connected to each and every person? That means, is it possible that each of these 10 million people, like each person is connected to every other person? The answer is No, right? Because it is impossible that any person has 10 million friends on the Facebook, right? So every person may not be connected to. However, it may be possible for some celebrity, for someone like has so many fan following, so many, they have so many friends, but not general case, right? It is not the general case like everybody has. So generally, a person may have at most, I can say like 10,000, or we can say like 50,000. Let us say 50,000 friends. But the 10 million is a huge number, right? So every person is not connected to the 10 million. So if we are, so what will happen if we will end up drawing the adjacency matrix. So we will end up drawing the adjacency matrix. So most of them will be empty. Most of the places will be left empty. Okay, right? I hope you are getting. So similarly, if we and in adjacency list, what happens? We draw only those much graphs which are connected. We don't consider the nodes which are not connected, right? So let us say this is one node, this is another node, this is another node, and this is another node, and this is another node. And let us say this is the these are the data at the back end of the Instagram. Okay. And now let me just show you, like, let us say like this person is friend with this person. Okay. Now let me say like this person follows this person. Okay. This person follows this person, and this person follows this person, and this person follows this person. And there may be some, you will also you may say like, hey, you are doing bias thing. Okay. So let us say like this person follows this person, and this person follow back to him. Okay. Okay. So now let us say this person follows this person, and this person follows back to him. Okay. And let us say this person follows this person also. Okay. That's it. So now if you are going to draw an adjacency list, so what you will do, you will be considering like and similarly you can take many more graphs. Okay. Let us say you can take many more nodes. There are one more nodes. Okay. One more nodes, and there are one more nodes, right? So now let us say these are connected with each other. Okay. So let this follows this person follows this person, this person follows this person, and this person follows this person. Okay. So basically, for this, so now let us number them. This is the node 1, this is the node 2. Not, don't consider it node, consider it as user. This is the user 3, this is the user 4 of Instagram, this is the user 5. Okay, this is the user 6, this is the user 7, and let us say this is the user 8, and we have the user similarly 9 and 10. Okay, so we have the user 9 and we have the user 10. So what will happen? This user follows this one, this follows this one. But you can see everybody doesn't follow each and everybody, right? And the same is the, I think, practical reality. At Instagram, Twitter, WhatsApp, anywhere, you may follow some persons, but you don't follow that. Like you are following your friends, you are following your friend's friend, you are following your friend's friend. So let us say it is you. So it is your friend, and it is your friend's friend, and you are following to your friend also, and you are following your friend's friend also. Okay. Similarly, so it is your, so he is your direct friend, right? And this user 4 is your friend's friend. Okay. And this user 5 is your friend's friend, right? And this user 6 is your friend's friend, right? And this one is your friend's friend. So many times when you will visit on the LinkedIn, I don't know how many of you are on the LinkedIn. So when you will visit on the LinkedIn, you will see something like this. Before there will, you let us say there is a user XYZ. So you will get something like third. Many times you will end up seeing this thing third. Sometimes you will say like there is an user ABC, and before his profile you will get like second, and sometimes you may get like first. You may get first. So what does it mean? What does this third, second, first mean? Basically, friends, it is the graph. They are representing that when they write the first, that means this user 2 For let it is the LinkedIn. So this user 2 is the direct friend of 1. So this is the first friend of 1. For this, so on the profile of, if this user is going to view on LinkedIn this user, so he will see this user as first. So after the name, it will be written first there. Okay. And if he is good, so and this person has this friend, okay, and this friend has this friend, okay. So you can see this is the first friend. This is the, in the case here the third is the first friend, right? Also third is also the first friend. So when he will view the third name of the third person, he will also get there the first. But when person one go to view the profile of person 4, so person 1 is not following the 4, right? But person 1's friend is following. So it will show second. So before the after the name of the person, it will show him the second. Similarly, so that means these are connected to each and everybody, right? So these are connected. So if you want, I can quickly show you these things. I can quickly show you, like many people, friends, many people use these things. Many people use always the link list, LinkedIn, but they never know like what they are saying. They always end up like, what is this 1, 2, 3, 4, right? But they don't know like what does that mean? Like what is the really meaning of that thing? So when you will go to the LinkedIn profile, you will get there like the person beyond each person, you will get something like that. Okay. So now let me just go to someone. Let me let me see his profile. So you can see I am getting here second, right? So I am getting here second, right? Similarly, let me go back and let me go for this person. So I'm getting here second. That means this person is my friend's friend. This person is my friend's friend. Okay. For this person, you can see I'm getting here third. So this is my friend. Okay. This is my friend's friend. Okay. This is my friend's friend. Okay. So they are the third. They are not the one whom I'm directly following, right? And the persons to whom I am directly following, let us say Satya Prakash Mal. So I am directly following this person. So I am seeing here first. You can see I am seeing here first. So I just this is not just for the that purpose, but just for the knowledge, for the sake of the knowledge, I wanted to just share it. So I hope it increase your knowledge a little bit about the LinkedIn. Okay. So these are the things that that are really helpful. So now you can see that graph is everywhere in your real life. Graph is everywhere. You can see the graph in the LinkedIn, there is Facebook. So what happens whenever, so basically whenever we make the friend, let this is me and I am making any friend. So I am following him, right? So at backend, what happening? I am just creating an age with that person, and let that person started following that some other person. So so how I will look at him, that he is following some other person, okay? And let this user is following some user 4. So I will see something like this, okay? And what happens? Let suddenly I started to follow 11. I directly started following 11. Okay, so what will happen if I started directly following 11? So basically this will happen. This will do nothing, but it will simply create a direct edge with me. That's it. I am started following this 11 also. So I have access to 11. So he will be the first for me. When I will view his profile, I will get the first at the LinkedIn. Okay, after his name, I will get the first. Like this is the first level of connection. So basically on LinkedIn, whatever you see, if I would like to, if I am about to summarize. So let this is you. So let these are your direct friends. Let these are your direct friends. Okay. And these are your friends. So you can see very beautifully now in your life, whenever someone asks you, please give me some example, like where you are using data structure, graph or tree like that structures, told him LinkedIn. Just told him like, dear son, you use LinkedIn, right? So LinkedIn is using that structure. Okay. So what happens when you follow? So the person to whom you directly follow, the person to whom you directly follow, they are they are at the first level. Okay. The person whom your friends follow, they are at the second level for you. And the person whom your friends follow, they are at the third level. And similarly, this list goes on. Similarly, this list goes on. Okay. So, so this is you and this is your friends, right? Your friend, your friend's friend. So for this person, when you will go, so it will, your LinkedIn shows that this person has is the first level. It is at the first level. This user at the second level, and this user is at the third level. No teacher is going to teach you such the real with such real life examples. Even you might end up like you are using the LinkedIn from last 5 years, 10 years, and you are not knowing this thing. Many people doesn't know. I don't know if you are an exceptional. So this is the next thing. So what happens? So you can see this person is not directly following all these persons, right? So why in the adjacency, if I am going to make an adjacency matrix for this person, so why should I store all other people? Okay, I should only consider like this is the root. Okay, this is the user. So the user is following let this node 1 and node 2. So I should only put 1 and 2 to save the memory, because this is what I have to do everything, right? So why should I store each and everything false? Okay, for this thing false, this thing false. So if I am going to use adjacency list, it will take only this much space. But if I will use adjacency matrix, okay, if I will use adjacency matrix, so I have to create an adjacency matrix of the size of this whole tree, cross tree. Less size of this tree is 100. So I will have to create this much. So you can see this is taking 3 bits. This is taking 3 bits of space, while this is taking 10,000 bits of space. So now, friends, I hope you might have understood till now, like why we can be why it is always preferable to use the adjacency list over the adjacency matrix whenever possible. Okay. So this is the one thing. Okay. Now let us go to the next slide and let us try to understand like now, like how to draw the graph, and how to do the things. Okay. So now let us try to draw some graph and let us try to do some steps. So how do you construct the graph for something? How do you construct the graph? So let me say like this is a tree. Okay. This is there is a graph. Okay. There is a graph and I need to construct a graph for that thing. Okay. There is, so first I will take very basic example, this thing, and this thing, and let us say we have this user also. Okay. And let me connect these things. So this is connected to this, and similarly this node is connected to this node, and this node is connected to this node, and this, let us say this node is connected to this node, and this node is connected to this node. So all I need to do is naming. This is the 1, this is the node 2, this is the node 3, this is the node 4. So dear friends, now we have this 1 2 3 4, right? So for this thing, let you are going to construct a graph. So in what does that graph means? Graph means that we should have this. So when we turn it into the code, we should have such capability that when someone look at our code, he can redraw this graph, right? The main motive to draw and graph is that if someone look at our code, he can redraw this graph. Okay. So now let us go and draw this graph. Okay. So in graph, what we need? We need like this node 1 is connected to node 2, connected to node 3, connected to node 4. That's all. Node 1 connected to 2, connected to 3, connected to 4. Similarly, node 2 is connected with what? Node 2 is connected with the 1, node 2 is connected with 3. So let us write just 1 and 3, right? Similarly, node 3 is connected to 1, it is connected to 2, it is connected to 4. So node 3 is connected to 1, node 3 is connected to 2, node 3 is connected to 4, right? Similarly, we can see node 4 is connected to 3, node 4 is connected to 1. So node 4 is connected to 3 and node 4 is connected to 1, right? So this is what we need to draw, right? So now let us, so we have talked a lot. Now let us move and go back to the coding. Let us try to perform something. So let me do some coding there. Okay. So now let me just go and open a new thing, new snippet, and let us Now we will be coding here. Okay. So in order to, so like if you are an user who has been come back to the JavaScript from the C or C++, so there's something called something exists called struct. But here, instead of instruct, you have to use the class. So now we are going to implement the graph. Okay. So class graph. Okay. Class graph. So we have this graph now. Class graph. So this is a class graph, right? So in like there you used to there you used to have one struct. Okay. So here you used to have constructor. Okay. So constructor. Okay. Constructor. Okay. So constructor, and for this constructor we should have one adjacency list, right? So this dot adjacency list. Okay. This just adjacency list, and since it is a list, so I am initializing it with a list. Okay. With an object. So constructor. Okay. Constructor, and we have this adjacency list. So now first we need to add the vertex, right? First we will create the vertex. What I am saying now. So
I think you paused the screen. Nothing to see.
Okay. Sorry. Actually, I was sharing the whiteboard now. That's why this thing happened. So, okay. So I will reconsider these things. So, is it visible now?
Yeah, it is visible.
Okay. So what we will be doing, we have to construct the adjacency list for the given graph. Okay. So we have to construct the adjacency list for the given graph. So what we have to do, let us say we have a graph. So let us say our graph is something like this. So let us say like we have the graph. This is the node. These are the nodes. There are 3 nodes. Okay. And 4 nodes. Let us say there are 4 nodes, and each of these 4 are connected something like this. Okay. This is connected to this, and let us say this one is connected to this. So first and foremost thing, we are very sure that our adjacency list have at least 4 vertex, right? Vertex 1, vertex 2, vertex 3, vertex 4. This is what is very important. So we must have this thing, and in corresponding to each of them, we will store like 1 is connected to which nodes. Similarly, 2 is connected to which node. Similarly, 3 is connected to which nodes, right? Similarly, we will be doing like 4 is connected to which nodes, right? So first thing, we have to draw this thing. We have to create these 4 things. So inside one list, we will creating 1, 2, 3, 4. Then corresponding to each of the vertex, we will make this key, and in its pair, in its value, we will store like with which nodes it is connected. Okay. So let us say it is the 1. Let us say it is the 2. Let us say this one is the node 3, and let us say this is the node 4. So Satya, hello. Can you tell me?
Yeah.
The adjacency list for this one?
Yeah. 1 is connected to 2 and 3 and 4.
1 is connected to 2, 3, 4. Very good. 2 is connected to
only 1.
Good. And 3 is connected to
3 is connected 1, 4.
1 and 4, right?
Yeah.
3
4 is connected to 1, and
4 is
4 is connected to only 1 and 3.
1 and 3. 1 and 3, right?
Yeah.
So this is what you have to draw. So you are very sure, like
this is the adjacency list.
So you have to draw first. So you are very sure, you don't know like with which node it is created, right? Connected. But first you know that you have to create these nodes, right? There might be a chance like there is a node which is not connected to anyone. So you have to draw that thing.
Yes.
Also. So first we will draw the vertex, then we will make the edges, right?
Yes.
So now let us go and try to implement this thing. So now let me just show you something very interesting. So now let me go there and implement a graph. Okay. So class graph. Okay. So we have this class graps graph. Okay. And here we will take a constructor constructor. Constructor. Okay. So we will take a constructor, and inside this constructor, we will initialize just what this adjacency list, right? This dot adjacency list, and this is list, so I'm initializing it with an empty object. So now first we need to add the vertex, so we will be adding the vertex. Okay, so add vertex, and we will pass the b, the each vertex, each node here. Okay, each node here. Okay, vertex b. So if what if this node already exists, there might be a chance like we are adding the vertex. Okay, so uh, so let me first show you. Okay, let me first show you. So first what we will do, this dot adjacency list, this dot adjacency list of the v, and we will create an corresponding array for that, right? But let us say we have created the node for one, we have created the vertex one in the graph, we have created 2 3, and again we are getting 4, and then again we are getting up 4 is connected to 1 again. So we don't have to push the one again, right? We don't have to push the one again. So in that situation we have to check like the vertex that we are going to create, the vertex that we are going to create, if it is not there already in the matrix, then we will be pushing this one. Are you getting, Satya?
Yeah, getting.
This dot if not adjacency list of vertex, if it is not already there, if it is not already there, then we will be creating this thing, otherwise we will not create, otherwise we will not create. Okay, so what we are doing, like if this dot adjacency list of vertex one, this dot adjacency list is there. Okay, so now this, so this is the very simple thing. So now let us see only this thing, like if we are getting any error, then we will correct it, otherwise we will move forward. Okay, so now let us let me create a graph. So let us say like I have graph let and don't use let us say yes, let g. Okay, because that is not secured, for security purpose that is not good always. So now let us say like g dot add vertex. Okay, g dot add vertex, let us say I am adding a, let us say I am adding g dot add vertex, I am going to add b, and similarly so now let me copy this thing and let me make this thing multiple times. Okay, sorry. Okay, so let us say I'm creating this no C, I'm creating this D there, I'm creating E there, I'm creating F, G, and H. So ideally, so now if I'm going to do console dot log G, okay, so ideally what we are supposed to get, okay, ideally what we are supposed to get right now, ideally what we should get here. Okay, so let us talk about that, what should be the output at this stage. Okay, so we are creating these things, right? So we should get what we should get, we should get this thing. Suppose, so we should get an adjacency list of something like this, like a initialized with this thing. Similarly we should get B initialized with empty array, and here we will put like with which nodes it is created. Similarly, C initialized with this, and likewise, so on and so forth. Okay, still H, we are supposed to create this thing. Okay, with this line of code. So now let us go execute this code and try to see like either we are getting or not. So wow, you can see we are able to achieve it, right? So we have created an adjacency list. Inside that list, we have A, B, C, D, E, F, G, H, and all of them are empty. Does it make sense?
Yes.
Good. Are you able to follow till now?
Yes.
Okay. So we are able to create the empty edges, right? So the only thing that is left here, we have to put like A is connected to with whatever node here. We have to put in the B, like B is connected to with which nodes, right? Right.
Yes. Yes.
Okay.
These
So
are created all.
okay, so now let us say I am going to draw let us say I am going to draw a graph. Okay, and for that graph we will connect something like this. Okay, so now let us say I am going to draw sorry, I am going to draw an graph. Let us say this is the A. Okay, I don't know, I'm sorry for the drawing if it doesn't go well. Okay, So let me, I will try. Okay, so basically this thing. Okay, so basically I want to just create this thing, something with the help of this. Okay, similarly. Okay, oh, why I'm doing this thing here? Sit. If I have this thing, great. So let us say what I'm trying to create is, I am trying to create, I have this A here. Okay, I have this A here, I have this B there. Okay, I have this B there, and I have this C here. Okay, and I have this D here. Okay, and I have this E here. Okay, I have this E here, and I have this F here. Okay, I have this F here, and now we will be connecting each of this. We will be connecting each of this. So A is connected to B, A is connected to C. Let us say B is connected to D, C is connected to E, and D is connected to F. F is connected to E, and D is connected to also this. Let us make it some critical. Okay, some are critical. Okay. So now let us say we want to create these things. So first and foremost thing was like B should have these vertex. So A, B, C, D, E, F. So we have A, B, C, D, D, E, F. So these are extra. So let us remove them. Okay. So now we have to create these edges, right? We have to create these edges. So in order to create these edges, we must have a function to create the edges, right? So let us go and write a function to create an edge. So let us say we are create create edge. Okay, create edge. So in order to create any edge, let you want to create a edge between A and B. So B must have two inputs, right? Two nodes. Like between which node you want to create the edge? A and B, or A and C, or D and E, right? So you have to pass two nodes, B1 and B2. Does that make sense?
Yes.
Okay. So we are passing on B1 and B2. So what we will be doing, this dot adjacency list. Okay, this dot adjacency list of v1 dot push b2, because we can we need to push b2, and similarly we have to push in b2 b1. Okay, so now you might be wondering, guys, like what is happening. So let me tell you. For this thing, when you are going to create an adjacency list, what you will do? Dear friends, when you are going to create adjacency list for this graph, for let us say for A, so what you will do? You will in the adjacency list of A, you will add B, right? And in the
Yeah.
B,
Yes.
you will add A, right? So basically, you will.
Yes. Yes.
So what I am doing? I am going in the adjacency list of A, that is adjacency list of vertex B1, and I'm pushing there B. I'm pushing there B2. Similarly, I am going in the adjacency list of B and pushing there A. So I am going adjacency list of B and pushing there A. Does it make sense?
Yes. Means
Good.
you try to connect a push into the A B list and B push into the A list.
Yes.
Right.
Yes. Because if there is any edge between two graphs, you are getting it right. If there is any node any edge between two graphs, so you can traverse A to B and B to A also, right?
Yes. These are
Similar.
so to the connections.
Yes. So basically this is an undirected graph, right? This is an undirected graph. So you can go from D to
Yes.
F and F to G, F to F. So D to F and F to D. So you must have to store both these things. Inside in the adjacency list of D, you will store F, and in the adjacency of F, you will store D. So that's why we are creating this link here. Does that make
Yes.
sense? So now,
Yes. Yes. I got it.
now let me create the edges. G dot create edge. Dear friend, nothing is tough unless until I am teaching. So we are going to create an edge between A and B. So let us say A and B. Okay, just be with me and keep telling. Okay, A and B. Now we are also going to create an edge. Satya, can you tell me all the edges? A to B, then A to
Yes.
A
Yes.
to
See.
C. Okay, 1 minute.
Yeah.
1 minute. We are going to create an edge between A to C. Then
create B to D
B to D.
and C to E.
Okay, we are going to create an edge. We are going to create edge between C to D.
D.
Okay,
Yeah.
so we are going to create an edge between A to B, then A to C, then B to D. Okay,
and D to E.
Creating an edge between C to E. Sorry, C to E. Okay,
E.
C to E, and we are
and
going
D,
to create an edge between D
D to E.
D to E. Okay,
and
D
D to
E,
F.
and we are going to create an edge between D to F, and we are going
and
to
E to
create
F.
an edge between E to F.
E to F.
E to F. So, is there any edge left? Can you count down 2 to 4, 3, 7, and 1,
Yes.
2, 3, 4, 5, 6, 7. So we are done, right? So
Yes.
now what should be the output of this thing? What should be the output of this thing? First, let us calculate. First, let us dry run. Okay. So A is connected to B,
B.
and C, right? B.
Yes.
B comma
and
C.
C.
1 minute. It is connected to BC. Okay. Similarly, B is connected to
D.
A comma D.
and D.
Right. Similarly,
Yes.
D is connected to
E and F.
comma F.
F and B. B also.
And D, F, and V, right?
B also.
Similarly, F is connected to
D and E.
D and E. Similarly,
And
E is connected to
E is connected to F and C and D.
Okay. E is connected to F. E is connected to C. E is connected to D. Okay.
Yes.
Similarly,
and
E is connected. Similarly,
C,
E is
C.
yes. Similarly, C is connected to A and
A
E.
and E.
A and E. So generally, 3, 3, 6. So we are not done with one node. Which one? A, B, C, D, E, F. So we have 3, 3, 6. Yes, we are done. Okay. So this should be the output, right? This should be the output. Okay.
Output.
So now let us just save this code. Let us execute it. Okay. So we have get this node over here. So now let us try to see it. So let me show you. Can you just verify, Satya, like this is the same that we are expecting?
Yeah, it is same.
So we are able to create the adjacency list of the given graph.
Yeah.
Isn't it?
I got it. Yes, sir. I got it, and it is look like very simple.
So this is so simple. There is only, you can see like 2 lines, 4 lines of the code, and we are able to do these steps, this much steps. It looks very critical, but when the people doesn't have the knowledge, okay. But I don't know why the people used to teach the things which they don't know how to implement, right? So
yeah.
So
yes,
this is as simple as it is. Now let us see. Let us. I want to give you some more thing. Like in your interview, someone might ask you, like, write a code to delete an edge, right? Someone might ask you, write an code to delete an edge. And I always want, like, my students, wherever they go, they're off there. Okay. So let us try to. Okay. So let us try to write something. Okay. So delete. Okay. delete edge. Okay, delete edge. Okay, so when we are going to delete any edge, we need to specify that this edge, right? That is existing between A and B, or B and C, right? So
yes,
we have to pass on that edge also, right? The vertex, right?
Yes.
So
Pass the
delete edge.
connections between two edges.
So we will be deleting the edge between B1 and B2. So how do we delete? We will be do this dot adjacency list. Okay, this dot adjacency list of V1 Okay, is equal to we will be doing this dot adjacency list of V1. Okay, V1, and from this we have to delete the B2. Okay, so B1 dot filter. B1 dot filter. Okay, and inside this filter B will take a vertex B, and B will go, and B should not be equal to B2, right? B should not
Yes.
be equal to B2. Just I am using my knowledge of the higher order function. That's it. I don't know whether I will
Yeah.
be able to achieve these things. These are as new for me, as new to you. This is right now I am thinking to implement this thing. I have never implemented this thing before. So
Okay, I got it.
similarly for the vertex 2, we will go inside the vertex 2, and we will be deleting searching for vertex B1. Okay. So this thing,
Yeah.
so now let us check it out. I think V1, then this B1, this. Okay, so this should work. So now let us say I want to delete. Okay, first let us look at the graph. So which node you want to, which connection you want to delete? Let us say I want to drop the connection between A and B, right?
Okay.
So from the adjacency list of A, there should not be B, and in the adjacency list of B, there should not be A, right?
Yes. Yes.
So let us say we want to delete, so G dot delete edge between A, comma B. Okay. So now let us go there and see it. So now can you look at these graphs earlier and after deletion? Is it the
Yeah.
same?
Yeah.
That should be.
No. No. B is deleted and A is deleted from B, and
So
B is
you are
deleted
getting,
from A
so
list.
you are getting this thing, right? Like from A,
Yes.
B deleted. So this connection has been removed, right? So that means
Yes.
I have written the right code, right?
Yeah. Yeah.
Good. So now, so there
Basically,
might,
filter return. Basically, filter return here, which is equal, not equal to the
yes.
vertex A
So
in.
yes.
Yes.
So basically, this is the logic. Okay. So the guys who are new to the video and they don't know like what is this filter function, so just go and check it out on the MDN side. So you will get it. Okay. So I'm not going to deep dive inside the higher order function, which otherwise I will deviate from this path. Okay. So this is okay. So now let us say like someone asks you to delete an vertex also, right? Someone might say like, hey, drop this A from here. I don't want to see the A, right? Some in, let us say
Yes.
there is an interviewer who asks you to delete the node. He's not asking to delete this edge. He's asking you to delete the entire node. So
Nodes.
so now tell me if there is a graph. Okay. Now tell me just only one thing. Okay, like friend. Let me have this graph. Okay, this, this, okay, and this. Okay. So now let us say this, and this. Now let us say we have this thing. So when we will delete, let us say I want to delete this one. I want to delete this node. I want to delete this node. So I have to remove this node from here also, or from everywhere, wherever this node is, right? Because after deletion, this will become something like this. After deleting this node,
Yeah.
it will become something like this, right? It will become something like this,
Yes.
and it will have only these connections. It will not have all those connections. It will have only this connection, right?
Yes. Yes.
So this node, this graph is becoming something like this graph. So I have to, in
Yes.
order to make this thing, I have to delete these node, these links also, right?
Yes.
So that means in in whatever vertex. So first thing is I have to delete that node, as well as in whatever vertex, let vertex we have to go to check each and every vertex, and if there is in each and every vertex, and if in the adjacency list of that vertex there is A, I have to delete that thing also, right?
Yes.
So
Means remove the connections between these one to
yes.
particular nodes to delete.
So let us say I want to delete here. I want to delete here. Let us say I want to delete here A. So this should not be there. If I want to delete here the A, okay, A. So first thing, A should not be there. This will be gone completely, because so there will be only this much vertex, right? If I am going to
Yes.
delete A vertex A should not be there, as well as if there is no A, So why there is a? This also should not be there, right?
Not there. Yes.
So this thing is what I am supposed to do. Okay. So
Okay.
a little bit tough. Okay. Let us go. Try to write the code. And if the code doesn't execute, I'm sorry. So the theme is we are going to delete what? Delete vertex, right? Delete
Yeah, vertex.
vertex. Okay, delete vertex. So in order to delete vertex, what we need? We need two vertex or one vertex?
Needs vertex.
One vertex. The vertex that you want to delete, right?
Yes.
Just that
Yes.
thing. With that information, we should write such code that is able to delete that vertex. Okay. So first, if we will delete that vertex, then we don't have any link to delete all these things. Okay. If we delete first A,
Yes.
so we won't be able to delete this A. So first we will traverse
Yes.
in through the adjacency list. We will delete each and every A, and at the end we will drop this A also. Okay.
Vertex. Okay.
So in order to traverse, whenever you want to traverse anywhere, you have only one thing called LOOP loop.
Loop.
That is, so let us use the while. Okay. Let us use a while loop, right? So while this dot adjacency list, while this dot adjacency list of vertex dot length, length. Okay, great. So then what we will do? We will do const adjacent vertex, adjacent vertex, okay, is equal to, we will do this dot adjacency list, this dot adjacency list of vertex B, and we will delete that thing from there. So dot pop. Good. I can use the pop also. Yes, I can find out that thing and I can delete that pop also. And then what I can do, I have to delete everything, right? So I will do this. I have to use the recursion. So this dot delete a, sorry, delete. So I have to delete that thing also, right? So adjacent vertex. So I have to delete age also, delete that age. If I will be deleting that age, so I need to pass that vertex. Two things, I need to pass the adjacent vertex also. So I'm passing the adjacent vertex, and once it is done, I will have to pass the delete that thing. I will have to delete that thing also. So I have to delete this thing. Okay. Yeah, I have to delete this vertex. So delete. Okay. Delete. I will delete this vertex from the adjacency list. So this dot adjacency list, this dot adjacency list of vertex. So this is the whole bunch of code, I think, but there might be that something I have left. So let me just quickly show it. See it, like I am doing just like delete vertex. Okay, so I'm doing just delete vertex. Good. Delete vertex. I'm using this like this dot adjacency list of b dot length. Then I'm doing the adjacent vertex is equal to this dot adjacency adjacent vertex. These are adjacency list of vertex dot pop. I am using also this dot delete age. I have to delete that age from the vertex, then I'm deleting this thing. I think this is, there might be some issue, but let us check it out. So let us try to delete. Okay, sorry, g dot delete a vertex a. Okay, g dot delete vertex a. So let me run it. So Bhagwan bharose. Yes. Oh my god, we are done. Hello.
Yes. Yes.
So you can see we have deleted a entirely. We have deleted this. There is no a and there is no significance of a. So
Okay.
next which node you want to delete in this, in among
Uh,
these, anyone?
E.
Okay. So you want to delete e. So let me just call g dot delete vertex. Okay, delete vertex and let us pass. Okay, so now let me go there and let me check it out. So now you can check. Now there is no e, right?
Yeah, is deleted. Yes.
So it is working fine, right?
Yes.
So I hope now you have a basic understanding like how you will create a graph, how you will create an edge, how you will create a vertex, how you will delete the vertex, how you will delete the edge. So these are the basic steps that can be asked by any company or anyone. So you must know, right?
Yes.
So
I have something doubt regarding to delete vertex.
yes,
In while loop, this that essential list of v dot length
yes.
means
This means we are going to traverse till the adjacency list of vertex b. So let us say I have this thing. I have this. I wanted to delete this e, right? We wanted to delete this e,
yes,
right? So we will pass
yes,
this e there, this e there. Okay. So
okay,
that means this thing. When we are writing the adjacency list of vertex c. So we are just indicating this array e. So
yes,
if there is
yes,
an e, so
yes,
what we will go, we will go inside this array and we will pop this e. We will pop this e,
okay,
right?
okay, okay,
So
yes,
yes, so we will go inside this, we will pop it. So when we will go inside this e, so we will go, so for this thing again inside this we will go inside, we will delete the edge e, edge between c and e, edge between
yes,
C and E. So
e,
when I will delete the edge between C and E, so the E will be gone from the C also, and E will be gone
yes,
from B also, right?
v also, huh?
So
Is
in
c
this,
also,
yeah, in this way we will be able to delete E from E and from C, right?
yes,
And what, and similarly if there, what if there has been another, if C is connected to A also, right? Let's C is connected to A also.
yes,
So it will not be empty. So while loop will run one more time, it will go check for A,
yes,
and it will go inside the A, and it will delete C from A, and again, and also it will pop the A from here, right?
yes, yes, yes,
So I hope now you got it.
yeah, got it,
So in this way we are able to delete each and every occurrence, right? Like each, like whatever has like if you want to delete this d, so what it will do, first first we will pass this here in the while loop. So
while loop,
first it will remove this thing, as well as it
yeah,
will go inside
mhm,
b, and it will remove this d from here,
yes,
and also then it will go this e, and from this e, okay, it will go inside the e, it will remove the d from there also. Similarly, it will go to this
yes,
f, and it will go inside the f and remove the d from there. So in this manner, we will be able to delete the d from each and everywhere, and then at the end
yes,
we will delete this d from this list.
okay, I got it.
So this
Means
is what,
connections of C which are which vertexes means traverse the vertex and copy it from the vertex and trying to delete the edge between these two vertexes from
yes,
the graphs.
yes.
Okay.
So these things many teachers don't know. Many teachers don't know. I think the teacher
Yeah.
that may be teaching you, but graph, he doesn't know this thing, so he will never tell you these things.
Yes.
So these are the things. Okay, so now if you are interested till now, then I can also cover the DFS, otherwise we can wrap it up. If you want, then it won't take longer, I can discuss the DFS also.
Yeah. Sure, you can take it.
Okay, so now for the DFS, like, let me share a new screen. First let me taught some concepts. After that we will come to, because I know that you know the concepts, but there might be few students who are watching this video later and they don't know like what the DFS search is. So let us say I have this graph. Okay, let us say I have a graph. Okay, and the graph is something like this. Okay, so now let me draw, let us say A, and I have this B, Okay, I have this C, I have this D there, and I have this E there. Okay, and I have this X there. Okay, so I have these things. So now let me tell you, like, let us say we have this is connected to this. Similarly, this one is connected to this. Similarly, this one is connected to this one. This node is connected to this node, and this node is connected to this node, and this node is connected to this node. Okay. So let us say these nodes are connected to each other, and this node is connected to this node. So in the what will happen when you are going to DFS search, perform the DFS search. So many times people will tell you something, but they don't give you the exact idea. So today your all the doubts are going to be clear. Okay, just follow me. So for the if it would have been the BFS breadth first search. So what we do in the BFS for this thing, we will traverse this thing. We will write this A there. Okay, then we will go the first level and we will traverse these two. We will write B and C. Okay, and similarly we will go to this level. We will traverse these two things. We will write D and E, and then
Yes.
we will go to the next level and we will write, and then we will write this X also. Okay, then we will traverse means this one also, and we will write the X simply. So this is the BFS. We are that is something like label order traverse. But if you want to perform the DFS, if you want to perform the DFS, all you need to do is you have to go one by one. So first you are going to traverse this A, right? You are going to traverse this A. Then what you will do? You are traversing this A. Then you have two options. Either you can B, go to B. So either you can go to C. So anyone you can choose. Doesn't matter. Let us say you want to go to B. So then you go to the B. Then again from the B, you have two options, either D, either A. But already A have been traversed, so you don't have to go there. You will go to D. So from D, you have two options, either X, either E. So let us say you want to go to A. So now this has been traversed. Now X has neighbors. Neighbor of X is D and E. D is already traversed, so you have to go to E. Now so E is also traversed. So neighbor of E are D, X, and C. But these are already traversed. So you will go to C. So in this way, you are getting one result. Okay. So this is very correct. Okay. This is very correct. So, but you know that DFS may have different answers. So let us say we want to traverse this thing first, then we want to go there. Then the adjacent neighbors of this node C are E only. E and A. A is already traversed, so we will go to E. So the adjacent neighbors of E are C, D, and X. But C is already traversed, so we will go to. We have the options to go to D and X. So this time I'm not going to X. Okay, I'm going to D. Otherwise, you will say like you always follow the simplest approach. So we are going to D. Then from D we have two things. Either we can go to B, either we can go to X. Let us say I'm going to B. Okay, so you might be wondering, oh, X shoot, yeah, X is left, X is left, X is left. No, friend. So you have gone to D, and from D, what were the neighbors of the D? You have to, when you are standing at any node, you have to traverse its neighbors, right? So you have traversed one neighbors, and this is already
Yes.
traversed, and this is left. So go and traverse this one also from the D, right? So in this way, you are
Yes.
able to traverse all the nodes, right? So this is the depth first traversal.
Search.
Why it is called depth first search, DFS? Because basically depth first traversal. Okay, depth first traversal. Okay, so why it is called DFS? Because we are going to deep. Okay, first here, then again we are going from here to here. That means we are moving down. We are not
Yeah.
iterating it over the label order. So that's why it is called um, DFS. Okay.
Depth first search. Yes.
So now let me perform something, and let me create an idea like what would be our. I hope you might be the people have listened about something called Brahmastra. So let us say like what should be our Brahmastra? Why how we will solve it? So first thing is we have to keep track like which nodes have been traversed. We have to keep track like what are the different nodes that have been traversed. So let A traverse. So that means we need an array, right? We need an array, which will be traverse array. Traverse, okay? Traverse array. In the traverse array, we will keep like which node have been traversed. Let A is traverse. So I will put it here. I will go here and I will make it true. Like A is traverse. Okay. Then again, when I am going at this node B, I will do. So I will go and check here like if B is there or not. There is no B. So what I will do? I will put here the B. I will push here the B. Okay. I will push here the B and I will make it true. Okay. Then again from B, I am going to C. I am going to D. Sorry. From B, I am going to D. So what I will do? I will put that D here and so on and so forth for each and every node. So we came to know that we need one array to store like what are the different nodes that have been traversed and which nodes are not traversed. Otherwise, we will end up traversing the same node in the loop. Like when we are going to D, we will go to E, we will go to D to E to C, E to A, then A to B again. So it will give us a stack overflow error as well as it won't give us the right answer. Okay, we will end up in a deadlock. Okay, we will end up in the deadlock. Okay, not typically that deadlock, but just for the fun I'm saying. So we will end up in the infinite loop. Okay, so we have to keep a track like which nodes have been traversed and which nodes are not traversed. So that's why we need an extra array. Does it make sense?
Yes.
Good. So now one more thing, can you tell me one more thing? Like if you are going to any vertex, so when we will write a function, we will write something, a function like, let us say I am writing like DFS search. Okay, DF search. Okay, let us say DF search. Okay, so okay, so let I am passing here and vertex B. So there might be that this vertex is it's not connected to any graph. This is the null vertex, right?
Yes.
So
Yes.
so if this vertex is empty, so this will be our base case now, right? This will
Yes.
be our
Yes.
base case.
This is.
So we can write something like this, like if vertex is empty, okay. So let us say DFS. Let us say something like this. So if vertex is empty, okay. If vertex empty, sorry, if vertex, okay, empty, then we will do, then what we will do, just we will return, okay, some base case.
Yes.
Okay, put the base case here. Otherwise what we will do, we will push this thing in the traverse array, right?
Traversal. Yes.
So we will push this thing in the traverse array, traverse array traverse array dot push. Okay, traverse array dot push this vertex. Okay, push this vertex.
Yes.
And also we can make it true. It's up to us. Okay, and the next thing what we will do, since we are traversing this thing, so we have to print at the end now. We have to print at the end the answer. So we have to store
Yes.
these things inside an answer array, right? So answer dot push,
Yes.
and we will push the vertex whatever we have traversed. So I hope the logic is very clear, right?
Yes. Yes.
So now let us go and write some code. So is it visible?
Yeah. It is visible.
Good. So now uh, let us say I want to go and I want to just go and just write this function. Okay, so let us say function, and let us say let us give it a name, DFS search. Okay, DFS search. Let us say DFS. Okay, let us say DFS. So we are going to the DFS. Okay, and we have to pass some vertex from where we will start, right? The starting vertex. Does that make sense?
Yes.
So we will start with the function and we will pass one vertex. And what we will do, we will check if there is no vertex, right? If vertex is null,
Yes.
right? If there is no vertex, sorry, if there is no vertex, then what we will do simply, we will return, okay, null, right?
Yes.
We will return null. Okay.
Null.
So we will end up returning null there.
Remove the function from
Okay.
front of the DFS.
Okay. Good. So we will return null there. Okay. And similarly, we will return the null from here. And also, so otherwise we will put it in an array, right? So VISITED, we can have, sorry, so first we will end up having some things, right? So we have not created these arrays, we have directly started writing the logic. So we have to create this thing also, right? So let us say depth first search. Okay, so we have to create those things also, right? So we have to, we are passing the start, we are not creating that array. That's what I forget. Okay, so we will create an array. So this, we will have an answer array, right? Let us say we have an answer array. Let us say we have an visited array, right? Visited array. So we have an answer array, we have an visited. So visited we will make an list, because in visited we will push the array and we will make it true, right? So, and then we have that adjacency list which we want to traverse. Okay, graph means adjacency list means graph. We need to have that graph. Okay, so this dot adjacency, I don't want to write every time this dot adjacency list. That's why I'm assigning it here. Okay, inside the function I will use it the same. Okay, because might be like at some point I miss this, then it will give me error. So why to take any chance? Okay. So now inside this, I am going to define a function. Okay. So I am going to define a function, and let us call this function with DFS again. And here I will pass the vertex B. Here I will pass the vertex B. Okay. Here I will pass the vertex B. So there are many more methods to do these things. One method is you can. So let me show you guys. You have ordinary seen this thing, right? You might have seen this thing in your entire life. But what if your interviewer asks you to write a function in other manner? So any idea, Satya, how you can write the same function in other manner?
Outside of the depth first search?
No. Actually, we are using this thing, na? Like function, then DFS. So,
Okay. ES6 model.
So you can also write it something like this, right? Like const DFS is equal to something like this, and you can also write function. This. And any third method that you know? Any third method that you know?
No idea.
Okay, so let me give you the third method. No one is going to teach you this method because this was very deep inside the documentation of JavaScript. So I got it from the GitHub. Okay, so I have never told it to anyone. Now today I'm just going to reveal it in the class. So function. Okay, so we will write this thing inside this thing. Okay, I said something like this in the parenthesis. We declare the function, then we declare the name of the function. Okay, and then we declare the parameters, like what parameter we want to pass it. Let us say we want to pass it the B, so we will pass here the B. Okay, and so we will declare this thing there. Okay, and the parameter with which you want to pass here. Okay, so the parameter that you will pass here to start this function, that you will pass at the last. Okay, so at the end you will pass start, because I want to pass here start, right? So this is the way how we write this type of function. Okay. So I
learned about this is first time.
Okay. So we use the function, we use the DFS, and then we use this thing. So now just go on and write the logic. So if B is not there, what we will do? We will return null. Right? Okay. And if V is there, okay. If V is there, 1 minute, I think somewhere something I am missing. Okay, good. So yes, so actually, so now let us, if B is there, so what we have to do? We have to push it in the array, right? So we will push it in the B state. Okay. So B state.
Visited.
Okay. Of vertex. Okay. And we will make it true.
Yes.
Right.
True. Yes.
So, and we will also push it in the answer, right? Answer dot
Yes.
push. We will answer dot push and we'll push the
B.
vertex.
Vertex.
Answer dot
Yes.
push, we will push the vertex. Okay. Good. So now, but the same thing, I have pushed just only one node, right? I have to do
Yes.
the same thing for each and every node, right?
Okay.
So when you want to do the some repetitive task, what you need to do? If you are repeating the same task again, you need to write recursion, right?
Yes.
Good. So recursion means you have to call this function, but
Function.
you have to call this function with every time with all other vertex, right?
Yes.
So where you have stored all these vertex in adjacency list.
Yes, adjacency list.
So you can use a for loop, and for each vertex, you can call this function recursively, and it will give you the at the end right answer. So
Yes.
and the second method is you can use the higher order function. So
Higher order function. Yeah.
yeah. So now you are the pro. So why to go with the normal approach, right? So let us move with the this approach. Okay. So we are going to pass
Yes.
the vertex. We are going to pass the for each. Okay. So for each, and in for each, we will try to pass like an adjacent, like all the adjacent node, right? So let us
Yes.
say I have the adjacent vertex, and for this adjacent vertex, what do I want to do? So here, what I want to do, if
First.
this vertex has been visited, if this vertex has been
Yes. Visited.
visited, okay, if this vertex has been visited, then we don't have to do anything. And if it is not
Yes.
if it is not visited, then we will call, right? Then
Yes.
we will call the DFS, okay, with this adjacent vertex, right?
Yes. Yes.
Does that make sense?
Yes. Yes. I make sense.
Good. So this is all. And at the end, when we are done, we are supposed to return the answer, right? Return result, right?
Yes.
So we have taken just answer array. So we can return whatever the answer array we have. So I think this. So just go through the code, right? So now, do you want to see the answer? Let us try it out. I don't know, it might be broke up somewhere, but I'm sorry guys, because this type of function I have written, I have learned about it, but I have written it second time. Once when I have learned it just not much more ago, 2 or 3 days ago, and this is the first time I'm going to use it, and with such a critical topic. So I might not be able to make it, but let us see. So depth first DFS, and let us say we want to traverse. So now I don't want to delete any node. Okay, I want to see this for complete node. Okay, so I have comment out that thing, and I am just going to pass the start node as a, and let us say I want to let answer is equal to this. Let us say output. Okay, let us say output of this is equal to this, and I want to do console.log output. Okay, output. And before that thing, I would like to see the graph also. So I can write this thing later on, right? I can write this thing. I can print this thing later on. So now let me just go and try to execute this thing. So this is the adjacency list. Okay, and this is the traversal. So you can see this is the adjacency list and this is the traversal. So please let me know, like we have traversed all the nodes, right? Right? A, B, C, D, E, F. This is the answer and this is the your list, right?
Yes.
So this is all about the DFS traversal, and please let me know if it was critical. At any stage you feel like you are not able to get anything.
No, I got it, everything.
And many things like LinkedIn portion, like LinkedIn first, second, third connection. Let me know if you were earlier aware about it or not.
No, I don't aware about it.
And do you think that how many persons knows about that thing when they say that first, second, third? They see, but they don't know, right?
Yeah,
No one tells them.
I think
Actually,
no one.
yeah, actually, I was going through the documentation of LinkedIn. So I got it. Every time I used
You
to
are
say like,
work hard. Yes, you
so
work hard today.
this is the thing that I wanted to put here. Okay, so guys, so I will put this code in the description. So those who have been writing this code, they can take it from there also. And so should I put it on the description or not? If I will put it on the description, many people will not see the video. So if they, so let us see them video. Okay, so that's all for.
No problem. You can put it.
So
No problem. You can put it. Many people
so
doesn't
this
understand about it.
so that's all for the day. So thank you, class.
Okay.